Do you know that your house has a heartbeat? Well, not just one heartbeat, many heartbeats from each and every electrical appliance. If you could measure all the heartbeats from all the appliances in your house, you would have a better understanding of the overall energy health. You might even be able to tell when appliances are getting sick. The key to the smart future house is good data, but that might be harder to capture than you think. Hey, Mike.
Hey, Ross. Good to meet you.
Nice to meet you as well. So you're trained as an electrical engineer, but your background is in speech recognition software, right?
That's right. Myself and a lot of the members of our team spent many years working on speech recognition, which means we take acoustic signals, which are waveforms, and apply machine learning algorithms to figure out what people are saying.
And now you're doing that inside the home?
That's right. We wanted to see, could we take that same kind of technology and apply it to the power signals coming in your house? Could we do analysis of signals and figure out what things are happening in your house to give users feedback about energy consumption, around patterns of usage and stuff like this?
It seems like a simple task, but I know many companies that have come before that have failed. They've been unsuccessful. And you don't have many options. You got the smart outlet that you plug a device in, gives you that device only. Then you have the whole cabinet with CT clamps on every circuit breaker, but you're still only getting what each circuit uses.
Yeah, we looked at all those sort of solutions before we started the company, and then realized that there would be an easier way, that if we measure the power coming in the house in this very detailed way, and then apply signal processing to it, we can figure out what's on and off and how it's being used.
So simple installation and device by device data?
That's right, that's right.
Wow.
So I tell you what, we got one installed in this house, so why don't we take a look and
Sure.
see what it does.
I'd love to.
Okay, Ross, let me show you how this connects in.
Okay.
What you see here is an electrical panel. We had an electrician open up the front of this so we could see inside. This is all live electricity in here, so there should be an electrician doing any work in here.
Yep.
But you see that these two, they're called CT clamps, just clamp around the two main wires coming into the house.
Okay.
And they just clamp around the wire. They don't even have to touch the wire really, just clamp around the outside of the wire. And these are what's measuring the power coming into the house. Now, this house has solar, so we have another set of CTs that are down here measuring the solar input, so you can see that separately.
So wait, so in a typical house, you might just only have the two CT clamps on the main power feed. Only if you have solar do you add the additional two.
That's exactly right.
Okay, got it.
Now, we also have to power the box and also measure the voltage coming into the house, and that's done with two wires hooked into a breaker.
Okay.
But then all those wires feed over here to this little box, which is essentially a little computer that is measuring the power in this very, very detailed way, and then figuring out what things are on and off in your house just by looking at the power signals.
And then how does that get out to the outside world?
It uses the Wi-Fi of the house. So you see there's a little Wi-Fi antenna here that's connecting up to your router and connecting up to the servers in the cloud.
Got it, got it.
Okay, so let me show you how this looks in the application then. You can see this on a phone, you can see it on a tablet.
Okay.
And what you're seeing here is a bunch of different bubbles. For example, there's a solar bubble that shows how much solar is being produced right now.
So this is solar production for this house right now.
That's right. So most of these bubbles are how much something's consuming, but of course solar is producing. So we actually show it as
So the
production.
orange one is for solar production, and then some red ones. What are those all
So the
about?
red one here right now is called always on. These are the things that are just always on in your house, like the TV that's not in a power saving mode, or your DVR.
Wi-Fi router, cable modem. Got it. So those are the phantom loads.
That's right. It's good for the homeowner to know that, because they can see how much power they're wasting on this stuff that's just on all the time.
No, that's great. That information is very key. And what about this unknown bubble here? Scale-wise, that's much bigger than the other two. What's going on with that?
Yeah, so unknown shows the things that the system hasn't yet figured out in your house. And usually that goes down over time. It's very big here.
So you're telling me that that's our TV crew, the lights, the battery chargers, and everything else.
Yeah, that's probably why it's so large right now.
Sorry, Mike, I'm sorry.
Then for something it does know about, for example, let me go turn the oven on and show you what happens.
Whoa, instantaneous.
Yeah, so suddenly, it's measuring at this very high rate. Suddenly a bubble pops up that shows you what the oven is
Electric
doing.
resistance oven, it comes on right away, tells me it's the oven.
That's right.
That is really key.
That's right. And you can see how much wattage it's using.
Wow, okay, so what do we have down here?
Yeah, so this down here is a history of different things that have been found in the house. So for example, you see when the oven just turned on recently, but you can also see when the garage door opened, or when the toaster was on, or the garbage disposal, and so on.
The information of your house. That is very cool.
Exactly.
And what about over time?
Yeah, so in fact, we have a way to look at a very detailed view of this.
So there's the daily.
So this is all the way down to the half-second level. So you see actually power coming in, and you see when the oven turned on.
So this is my solar production right here on a half-second scale.
That's right.
And this is the actual consumption of the electrical appliances in this house.
That's right. In fact, you can scroll way out, and you can see this for the last hours and even days and weeks.
That's really cool. All right, so this is all constant loads right now, instantaneous. What about variable loads?
Let's go take a look. I think there's a front-loading washing machine downstairs.
All right.
Yeah, so I just turned on the wash here, so you should be able to see it.
Look at that.
Yep,
It's
there it is
on.
in the application.
So when it's consuming power, right now we can see it. The washer's on. We can see the relative scale. Look, it went away.
That's right. You can see that this runs for a little while, then it takes a break as the clothes slosh around.
And then it's back.
That's right. So not only are we showing that the washer's on, we're showing exactly what it's doing at that moment in time.
That is very cool. So the relative scale I can see relative to the solar production, the unknown loads, the always on loads. I can just see it disappeared. But you're telling me you can get all that data from the 2 CT clamps that we saw earlier?
That's right. There's no sensor that we have on this washing machine. It's just from the power coming in the house.
How do you do it?
Well, I'll tell you what. Let's go to our lab and talk to some engineers. We'll show you how it works. Okay, Ross, I wanted to bring you to our office and have you meet a couple of our data scientists and engineers. This is Caleb, this is Emily here also, and Rinwa is going to show you some data.
Okay.
Hey,
Very
Ross.
cool. Hi.
How are you?
Doing great.
So we're looking here at the two-phase data recorded by the CT clamps.
Okay.
And over here, I'm going to show you the power signal for a front-loader washing machine.
Okay, so is the top graph the first phase of 120 volts, then the second graph is the other phase of 120 volts?
Correct.
Gotcha. Okay.
So the system is able to record the data at such a high level of detail that we can grasp the particular electrical signatures for that washing machine. So I'm going to zoom in here on a section of the wash cycle and show you the motor that is rotating the drum. So right here we have the motor rotating for 10 seconds in one direction and then pausing for around 6 seconds. And the data is so detailed, we can see the fluctuations in the motor due to the clothes sloshing in the drum.
So literally the little abruptions up and down, that is the agitation going on in the drum.
Exactly.
Wow. Okay, cool.
Yes.
And by the way, it's these kind of patterns that the engineers here are learning about and then programming into the system to make the system learn then for your house when the washing machine is on, when the dryer is on, and so on.
So you are creating a library or catalog of basically every appliance within the home.
Yeah, it's based on both an understanding of the device itself and observing the data. And I think Rinwell has some more data here that we've been seeing.
Yeah.
All right.
Actually, guys, check this out. I wonder if you can you guess what it is, Ross?
I have no idea.
I'm going to zoom in. Perhaps that would help. So we're looking actually here at a furnace. So this is the electrical signature of a furnace.
Okay.
Here, the furnace starts with an inducer motor turning on, and that blows the gas in the direction of the flame. This furnace is a spark igniter furnace, and right here is the spark igniter turning on.
Gotcha.
And people who own spark igniter furnaces can also hear it ticking.
So that's that tick, 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 tick
Yeah.
as it starts up.
And I think
Exactly.
if you zoom out on this one, we see one later on that actually has a really interesting pattern that we learned later, which is whether these things might fail or not. So far we haven't worked on this, but in the future we will use this kind of technology to determine is your furnace even working correctly. So you see here in this example, you see it actually took 3 times before it started. So obviously the spark ignition was failing and it had to keep trying.
So normally it would just take 1 ignition cycle for it to start, but in this case it took 2 additional times, which is significant of maybe some kind of issue with the furnace.
Yeah, in fact, this is a known sort of problem with furnaces, and normally you'd have to have someone come to your house and diagnose it, and here we just see it in the data.
So we're taking an emergency call in the dead of winter and actually just making it a routine service call.
That's the plan.
I like that. All right, cool. Thank you very, very much, Rima.
Thanks
You're
very much.
welcome, Ross.
Well, Mike, you've got a very unique system. The fact that you can get 2 CT clamps on an electric panel and get that much data, very impressive.
Yeah, thanks a lot. And yeah, we're actually measuring the power at 1,000,000 times a second. We didn't show you all that down there, but the amount of data we have now is just amazing.
Wow. And so what does the next 5 to 10 years hold for you guys?
Well, in the near term, what we're focusing on is just expanding that library that you talked about down there, both to determine when things are on and off in your house and how much power they're using, and then eventually doing the kind of fault diagnostics of the furnace, for example, and other things that might go bad in your house.
And do you think one day this will be part of the common home, the average home, new construction?
Yeah, we certainly hope so. I mean, we're focused on the software part of this, and look, eventually we think that the hardware part of what we do becomes part of like the breaker or the electric meter that's on the side of your house.
That's amazing. So I can't wait to see what happens in the next 5 to 10 years for you guys. Very excited. Thank you very much for your time today.
Thanks a lot, Ross.
Thanks, Mike.
See you.